In this lecture, we'll discuss the hypothalamus and the pituitary gland. Your hypothalamus is part of your brain, so it's part of your central nervous system, and it controls your pituitary gland. Okay, so in our image, this area up here is your hypothalamus, and it directly controls your pituitary gland right below it. Your pituitary gland, we have an anterior and a posterior section. And your hypothalamus is really kind of the boss of your anterior pituitary gland. Your hypothalamus is going to secrete some hormones. We have releasing and inhibiting hormones. These two categories are kind of nice because they tell you what's going on. Your releasing hormones will cause your anterior pituitary to release another hormone, while inhibiting hormones will inhibit your anterior pituitary from releasing another hormone. So in our image, our hypothalamus can secrete a releasing hormone. We can activate our anterior pituitary gland to secrete, for example, growth hormone. Growth hormone can then go activate different processes in our bodies, and we can see lots of effects. However, if our hypothalamus starts to secrete an inhibiting hormone, we will inhibit our anterior pituitary gland. We will not be releasing growth hormone, and so all these effects will stop taking place. Now, we have 5 releasing hormones we would like you to familiarize yourselves with. We have growth hormone releasing hormone, corticotropic releasing hormone, thyrotropic releasing hormone, gonadotropic releasing hormone, and prolactin releasing hormone. Some of these are hard to say, y'all. Some of them are hard to spell too. We just have to do our best. You will notice that each one also has an abbreviation associated with it. You are going to want to familiarize yourselves with both the full name and the abbreviation. Okay, you will see a little bit of both on your homeworks, your quizzes, your exams, etc. We have 2 inhibiting hormones we would like you to be familiar with as well: growth hormone inhibiting hormone and prolactin inhibiting hormone. Again, we've got our abbreviations as well. So if you take a look at this chart, we have our list of releasing hormones. We've even mentioned our 2 inhibiting hormones. And this shows us exactly what anterior pituitary hormones are affected by our hypothalamic hormones. Okay, we can even see our target organs and the effects. Okay, so we are going to go through each one of these pituitary hormones, their targets and their effects, little by little, one at a time. But for right now, we can at least get an idea of what these pathways are going to look like. All right, our hypothalamus also produces 2 more hormones that we haven't mentioned yet, but these are not called releasing or inhibiting hormones. These 2 are a little bit special. Okay, your hypothalamus is going to produce oxytocin and antidiuretic hormone. Antidiuretic hormone can be abbreviated to ADH, but it is also known as vasopressin. So just in case you see that term somewhere, vasopressin, ADH, same hormone. Okay. Now, the oxytocin and the ADH, what makes them so special? Well, the hypothalamus produced them, but they are secreted by your posterior pituitary gland. We haven't really mentioned him yet. Okay, so your hypothalamus produces the oxytocin and the ADH, and then it sends it to the posterior pituitary for storage. When we need these hormones, your posterior pituitary gland will be the one that secretes them into our bodies. Your posterior pituitary does not produce any hormones by itself. Okay, and that is pretty different from the anterior pituitary. We're going to see very quickly in the next slide or 2 that your anterior pituitary both produces and secretes quite a few hormones. So that's a pretty big difference there. See, look, we're already at the pituitary. I told you, it's coming up. So we've mentioned repeatedly now there is an anterior and a posterior version to your pituitary. There are some notable differences. We did just mention one, Okay, we said our posterior pituitary does not make any hormones itself. It just releases the oxytocin and the ADH that have been produced in the hypothalamus. Where anterior pituitary works a little bit different. Okay, you can see these 6 hormones listed here. Every one of those was both produced and secreted by your anterior pituitary gland. Our other notable difference is the type of tissue that composes these structures. Your anterior pituitary gland is glandular tissue. This is a full-on endocrine organ, while your posterior pituitary gland is actually neural tissue. Okay, so that's quite a bit different. Now, let's start in one at a time. Your anterior pituitary, again, we've got our 6 hormones here: growth hormone, adrenocorticotropic hormone, prolactin, thyroid stimulating hormone, follicle stimulating hormone, and luteinizing hormone. Again, some of these are a little hard to pronounce, some of them are a little hard to spell. Just got to practice. Now, all 6 of these hormones are protein hormones or amino acid hormones. We've mentioned them previously as they work through second messenger systems. So each one of these hormones would bind to a receptor on the plasma membrane. Once we have that activation, we can start amping up production of CAMP inside the body, that second messenger, or inside our cells, excuse me, and it acts as a second messenger to create physiological changes within the body by activating or inactivating those protein kinases. Okay, so if you still have not mastered the second messenger system versus the direct gene activation system, make sure you go back and review those quickly. Alright, here we go. We're going to take each anterior pituitary hormone one at a time. We're going to start with growth hormone. This is probably going to be your favorite one because guess what growth hormone makes you do? Yes, you are a genius. Growth hormone makes you grow. Okay. We have lots of different target cells here: body cells, bone cells, skeletal muscle cells, liver cells. Okay. We're going to do growth. We're going to increase in size. We're also going to increase in the number of cells. So we're going to have to do mitosis as well. We're going to have to do cell division. Okay. Now, this one is pretty easy and straightforward. Y'all better take it when it is easy and straightforward. Some of these are going to get complicated. Now, we can inhibit growth hormone. Okay, so your hypothalamus can secrete growth hormone inhibiting hormone. Okay, we mentioned him a couple slides ago. This is also referred to as somatostatin, so you might hear that term come up throughout the semester in, homeworks, quizzes, other videos that you might watch, things like that. So if you hear that term, it's just an interchangeable term for the inhibiting hormone here. Now, things can go wrong. We can hypersecrete growth hormone, or we could hyposecrete growth hormone. So if you hypersecrete growth hormone, if you're secreting too much, if you do this during childhood, we refer to it as gigantism or giantism, you're going to grow really, 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 really tall. Okay? 8-9 foot tall. Every tall person that you see on the street does not suffer from gigantism. Okay? Just FYI, not every really, really tall person does. And that's okay. But people that suffer from gigantism, in addition to just being really, 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 really tall, okay, they do suffer other medical conditions. There are trade-offs for becoming that tall. Your body has to work a lot harder to keep itself alive that way. Now, if instead you hypersecrete growth hormone during your adulthood, okay, so you are a full-grown adult, you haven't hit a growth spurt in 20 years, your bone plates have fused, you hit 5'5" and that's all you ever got, but now you're suddenly secreting growth hormone again. You are not going to get extra, extra tall, so you're not going to go from 5'5" to 5'11". Okay. Instead, you are suffering from acromegaly, and this gentleman, Rondo Hatton, okay, this was pre-acromegaly for him. He had not yet started hypersecreting the growth hormone. In fact, this man was voted the most handsome boy in the class of 1913 in his high school. This is the same man many years later. He is not wearing a mask. He is not wearing prosthetics, anything like that. But you will notice the major changes in his facial features. That is the result of his acromegaly. So he did not get taller, but his facial bones have started to move around. You have physical deformities, things like that. The hands are also usually misformed a little bit as well from the extra growth hormone. Okay. Now, last but not least, we get hyposecrete growth hormone during childhood. Okay. So you're not getting enough growth hormone, you're not growing super tall. This woman is suffering from pituitary dwarfism. This chair is just your standard dining room chair. It's not a tiny baby doll chair or anything. It's also not, a giant chair. Just a normal chair. And this is just as tall as she got. Okay. All right. So growth hormone's pretty easy. Thyroid stimulating hormone is also pretty easy. Your thyroid stimulating hormone really does stimulate your thyroid gland. If your thyroid gland is stimulated, it releases thyroid hormone. And there you go. We can stimulate your thyroid gland to release thyroid hormone, or we could not. Those are our options. Okay, thyroid hormone, which we will talk about in more detail, is your main metabolic hormone. So this one also plays a role in your growth and development. Okay, but for right this second, that's it. TSH stimulates your thyroid, which releases TH. Adrenocorticotropic hormone, a little hard to say, a little hard to spell. Okay. ACTH targets your adrenal glands. Okay. This will stimulate your adrenal glands to release additional hormones. So again, when we talk about your adrenal glands in more detail, we will talk about several more hormones that are being secreted by your adrenal glands, and they all have different functions and different target organs, so we'll go into more detail later. But for right now, ACTH from your anterior pituitary stimulates your adrenal glands to secrete more hormones. All right, follicle stimulating hormone, FSH. We have dual functions here because we have responses in males and different responses in females. Okay, so this is a reproductive hormone. In males, FSH stimulates sperm production in the testicles. In females, we are going to stimulate the production of estrogen. In order to do that, we do have to have the FSH work with your luteinizing hormone, or LH. Okay, so those have to work as a team to stimulate estrogen. And then FSH also triggers the maturation of an ovarian follicle, which is where eggs develop every month. Okay, so we saw the stimulation of sperm production, testicles, so that's one gamete. And now we're saying that we're triggering the maturation of ovarian follicles, which is where eggs develop. So our other gamete is developing also. So follicle stimulating hormone, one of the major functions is helping us grow and develop those gametes, those sex cells, those sperms and those eggs. Now, luteinizing hormone, LH. Okay. Again, we see different effects in males and females here. In males, we are stimulating testosterone production in the testicles. Okay, so FSH stimulated sperm production, LH is going to stimulate testosterone production. In females, we just mentioned that LH works together with the FSH to stimulate estrogen production, so that's still true. And we now have the release of the mature oocyte, okay, being triggered by LH secretion. So when we talk about reproduction, you will hear us talk about the LH surge. Okay, this causes ovulation. So around day 14 of the menstrual cycle, LH just floods the system. Okay, it surges in secretion. This actually triggers ovulation. That egg that we have been growing finally pops out of its little follicle, and it heads down the reproductive system, and it may or may not come into contact with the sperm. All right, prolactin. Our target cell is the mammary glands. Okay. We stimulate the growth of the mammary glands, and we initiate the production of milk after childbirth. Okay. So most people are familiar with the term lactation, and they already know that that refers to milk production. Okay. So now we know the hormone associated with that process. This can be inhibited. Okay. We have a prolactin inhibiting hormone. You could refer to it as dopamine instead, if that makes more sense to you. One of the interesting things about prolactin is that our normal, everyday, good old homeostatic state, okay, everybody remembers homeostasis, your normal state with regards to prolactin is actually to inhibit it. Okay. So think about it. If you are female, if you have not just given birth, you probably don't really want to or need to make milk on a regular basis. So on a normal, regular basis, we would actually have PIH, our prolactin inhibiting hormone, playing its role in inhibiting the prolactin, so we would not normally be making that milk. Now, if we do happen to go through labor and delivery and bring this beautiful baby into the world, that PIH secretion will stop, prolactin can take over, and that milk production can start. All right, posterior pituitary. Okay, we mentioned earlier it is neural tissue. We've said the oxytocin and the ADH technically come from the hypothalamus. They're just secreted by the posterior pituitary. But right now, let's make sure we know what these hormones do. So oxytocin, okay. Target cells are the uterus and the mammary glands. Two functions here. First, smooth muscle contraction during childbirth, okay, also known as uterine contractions. We're going to stimulate those. And then the contraction of your milk glands. We call this milk letdown. Okay, so prolactin helps us create the milk. Oxytocin actually helps us to expel the milk so we can feed the baby after it's been born. And then we have antidiuretic hormone, ADH. And again, we mentioned you might hear it termed vasopressin, and that's okay too. ADH works on your kidneys. Okay. The major function of ADH is to increase water retention so we can help prevent dehydration. Okay. When we increase water retention, okay, we will increase your blood volume, okay, which increases your blood pressure. Okay. ADH is inhibited by alcohol. Okay. If you are familiar with the effects of alcohol on the body, one of the common side effects of alcohol consumption is the need to urinate frequently. That comes from the inhibition. Okay, we are inhibiting that antidiuretic hormone, so instead of retaining that water, we are now expelling that water via urine. Okay. The other function of ADH, it causes vasoconstriction, which also directly increases your blood pressure. We will mention ADH quite a few times in several different body systems. So this is definitely one to put a star by and make sure that you have mastered the functions of this hormone. Things can go wrong. Okay. You could hyposecrete ADH. You could have a pituitary tumor, you could have a head injury, something like that. If you do not secrete enough ADH, okay, you are going to have some common symptoms. Polydipsia, polyuria. So you're going to drink a lot and you are going to pee a lot. One symptom you won't see is polyphagia. Okay, so a lot of times you'll hear people talking about diabetes. Okay, if you suffer from diabetes, then you're going to have polydipsia, polyuria, polyphagia, the 3 P's. Okay, well that's type 2 diabetes. It's diabetes mellitus. Okay, the one that's associated typically with being overweight and having a poor diet. Okay, diabetes insipidus, okay, has nothing to do with nutrition, anything like that. This one is due to hyposecretion of ADH. Okay, so although you see the polydipsia and the polyuria, you do not see the polyphagia. Okay, if we think back to our previous slide and the functions of ADH, normally we are retaining that water to help us maintain our blood pressure, things like that. Well, if we are hyposecreting, then we are no longer retaining as much water. So we go to the bathroom more often, and the more often we go to the bathroom, we're going to get thirsty. And we're going to try to quench that thirst and replace that water, so we drink lots of water. Unfortunately, we're just going to urinate all that out as well. And that concludes our discussion on the hypothalamus.